This is kind of the Bristol section of the Luftdaten and Telraam projects. They're both sort of these Europe-wide international projects that center on air quality data and traffic data, and we kind of use both of them to kind of create this understanding of the air quality in Bristol. With the Luftdaten project, we're focusing mainly on PM 2.5 and PM 10 because of the growing sort of wood-burning stove issue that's kind of spread throughout Bristol. Especially because Easton's at the bottom of the M32, so all wood smoke particulates, even though it's not an issue you'll typically find in lower income communities, always ends up just coming down and hitting us quite hard. Especially with Bristol's clear air zone, it's become more and more relevant to add to the conversation. And people in the clean air zone typically end up just blaming cars, because that's our biggest understanding, especially with the massive ozone conversation that happened from like the 80s to the 2000s. Everyone thinks that like it's aerosols, it's cars, it's devices, and we're trying to explain, no, they sometimes have a more natural cause, but it's quite difficult. So we use the Telraam data to show that there might not be as big a congestion issue in certain areas and to focus in on the actual specific causes. So we have three main data sets that we use. The first is the Telraam data set, which collects information on cars and the direction that they're going. So this is the Telraam sensor. It collects visual information, which is then sent remotely through the Raspberry Pi in the actual motherboard, which is housed in this little section here. It's sent to a computer in Belgium where it's processed using an AI, which can sense the size of the vehicle and decide whether or not it's a normal car or a cyclist or a pedestrian or heavy vehicle, and then analyze that information. Because of GDPR, it disposes of that information immediately. And so all it keeps is the numbers of the vehicles going down a specific road. It also collects the speeds at which that vehicle is going, since car speed seems to be one of its more popular uses. It also collects information on the time of day and how congestion kind of changes throughout a 24-hour period. It also collects legacy information. So you can see the huge numbers here from St. Mark's Road, and that's from information over time, likely a week or maybe even a month. Another data set that we collect is the PM 2.5 and PM 10 data from the Luftdaten project. Now, I've actually had multiple meetings with the guys who actually run it. They're very sweet, but the whole point of it is to collect particulate information from all over a given region or city. So the sensors are typically in a bit of grey drain pipe, and it's like a plastic hose that goes straight to a thing that will process it right there. And then once it has that information, we'll send it to a computer where it'll be mapped out internationally. It's expanded quite a lot considering that it's a very inexpensive sensor, and one of the biggest roadblocks to sensors is pricing. They're freakishly expensive, so having something that's so cheap, inexpensive, and easy to put up and keep safe makes it very valuable.